Hello everyone and welcome back to our studio, 1C Game Studios. Today we continue our series of conversations about the development of our new combat flight simulator, Korea IL-2 series. Our guest with us today is, every time we have key people really, but today, maybe. The key person here is Sergey Vorsin. He is our lead programmer and the project architect. I think Sergey will now tell us about when he joined the team and how it all began. So, hi.
I joined the team. Even before you, back in 2006. Yeah, you're a newbie here, that's for sure. Yeah, really, and before me, the team was already formed. But there was also Gennadich team. There was some kind of first team. So we started working on Rise of Flight. There you go. What else to say? Well, it was relatively successful. Back then, everything was just beginning. There was no Unreal Engine, no Unity, there was nothing yet. Everyone had to... Yes, that was still the era where everyone wrote their own engine. Well, not everyone, but if you wanted to make a game, you had to develop most things on your own. The engine and everything else required as well.
Yes. Well, it turns out that from the very beginning, you joined this small group of guys who were really into it, working on the core of the engine.
Yes. Do you mean with the Gennadich team? Well then, yes, we had about 5 or 6 people working on the engine, not counting artists and modelers. I still remember everyone's names, but I guess it's not that interesting. We were developing the render specifically, working on the network part, and we hired a separate person for that. Then we were already dealing with interface engine questions and the interface itself. We decided to go with Scaleform, because back then both Flash and Scaleform showed promise.
Yeah, it was a rapidly evolving technology back then.
Yeah, well, the render was based on the DirectX API back then in those days. So, what else is there? Well, let's say at that moment we were basically starting from scratch, so there was a lot that needed to be done. There was a lot of work to do, but surprisingly enough, we had the final result as early as 2009, just 3 years later. Roughly it was from 2005 to 2009, up to 5 years in total. But I worked on it for 3 years. That's when the first release of Rise of Flight, the first Great Air War, was published.
Yes, our first release took place at the end of 2009,
Yes.
if I am not mistaken.
Well, what else is interesting then? Let me think. Before that, I was familiar with aviation simulators, and I had developed some projects in that field. Well, so the active development started in 2005 or 2006, and basically after 3 years, well, we got some kind of... Let's say the engine was already 80% ready and the product was basically done. Then we were improving it for about 2 more years. Well, it's like that for everyone. Yes. Right? And then we started the work on IL-2 in 2012.
Yeah, and after that, it looks like Sergey and I will meet several times in dev briefs because he is responsible for many things. As a lead programmer, project architect, not just graphics programmer, and also for the so-called game world, for the physics in much of the game. But these are all big separate topics of conversation. Today, our topic will be about so-called bots. There. Boots? Boots. What are boots? Well, boots are not the same as shoes, right? Why bots? And overall, how did it happen that in-game characters are called bots?
Bots are a thing that has been around for a long time. Well, in general, a bot is short for robot. Well, it's a technology that has been massively used in gaming and development circles for quite a long time now, yes. Well, as far as I know, since the times of Counter-Strike, where you could spawn and configure these bots and all that. Well, before that, I don't know, maybe in Wolfenstein they used the same terminology, but it's just kind of stuck, at the very least. At least in our project, this is the legacy of those times. Yes.
Well, yeah,
Yes.
for sure.
Well, that's exactly how it came into use, exactly. By association with those bots and shooters. Because a bot and a shooter is kind of like what we have. Usually, it's an NPC character who, let's say, performs some kind of task. They have gaming roles. Well, for example, in the case of Counter-Strike, they are terrorists or counter-terrorists are basically virtual fighters. That's it. But you're actually playing as a bot too. Just your bot is controlled by your keyboard. And that's how it started. All these in-game dummies. Some people call it differently. Some call it human. I
didn't know that.
Yeah, I found out that at wargaming, they call them humans, not bots. Like, they refer to them as people.
That's interesting.
But we call them bots, and for us, they are bots.
By the way, you pointed out a very crucial point. It was almost the same in that context, but actually, it's important. In advanced architecture, from some point of view, the character witches. Some basic class that does something, yeah. It doesn't matter if it's controlled by AI or a person. It's roughly the same implementation.
Well, actually,
really.
It depends on the approach, but ideally, of course, well, if you strive for unification, you end up with, ideally, naturally, this external shell or avatar should be common for both the player and the computer, which is also important for fair gameplay.
Right? And it's obvious to the player anyway that when you're playing, the bots don't have the limitations like you. Conversely, when the rules are the same, it's easier to follow. It's like, well, it's cool in any game. It adds a kind of immersion to it. So, if we're talking about Counter-Strike, for instance, or any other online shooter, there are fundamental differences between them and us in terms of network architecture organization.
Of course. After all, we have a simulator, not a shooter.
And we should mention it in the context of the bot topic. Because, of course, we're asked when we finally get to switch planes in the online game from any plane to any. And like in some games, you can jump from a F-22, take down a pilot in an Apache with a rifle shot, hop in, and capture his helicopter in the air. There are amazing videos of that. We need to explain why it's possible there, but in a complex flight simulator, it's still a very difficult task.
I mean, we need to explain. Where are we limited in terms of this bot's interactivity with the environment?
Online, yes. That is a proprietary server, so why isn't ours proprietary? And thus,
a proprietary
this imposes
server
restrictions.
is a more technical term for ordinary people. It can be simply said that, like, if we're talking about a hypothetical battlefield game, Battlefield, where there are some controllable entities like tanks, cars, and airplanes, right? Some characters can switch them. Well, you have to understand that. All this tech is being calculated somewhere. These calculations can occur on the player's PC, or it can be done on the server, or on a machine that is hosting the server. So accordingly, if we're talking about a game like Battlefield or, say, Counter-Strike, well, there are no particularly complex physics involved, and let's say rules of modeling. All these vehicles, yeah, and the game world, there it is relatively light computational load, meaning that a server has a lot of free computational time, and you can accordingly calculate all this. The server calculates all these cars and tanks if there's a relatively simple battle implementation.
Yes, it's all calculated directly on the server.
Well, in one process, let's say, roughly speaking, one server process. So, if we're talking about a flight simulator where we have highly detailed models of physics, aerodynamics, contact, landing gear, and the terrain itself, then you get a very heavy load on the processor. And in our case, we're using a distributed computing system, so we've got every client, so to speak, calculates their own aerodynamics model. Consequently, it turns out that so if you, let's say, you hop in someone's plane and then this player disconnects from the server, you're left without a plane. So it actually turns out, and I'm not even mentioning that, the concept of control, let's say we have a plane that is quite detailed in terms of physics and controlling the plane, like the response is, to the steering, you have the feedback as well. By the way, force feedback
Generates a decent data stream coming in.
Yes. Accordingly, there are a lot of controls, unlike in Counter-Strike, where you have a mouse and there are 4 buttons here, but it turns out to be a lot. Here, the data comes from a joystick, from the input system as a whole, through the network. It's tough to transmit, especially over the internet. It's still more or less realistic through a local network. Over the internet, it is more problematic. And accordingly, we come to the fact that a distributed computing system, that is, each client has its own plane, and accordingly, you can't just have a network player hop in anywhere. You can have it sit in your aircraft. In other cases, it's unlikely to succeed because there's a major lag over the internet with input. You basically end up with something like it's one thing if, for example, I'm playing online and my ping to the server is short, but this guy has half a second, you know? It turns out that if I control his airplane, it will get much worse. I will get over a second of ping. Playing with this is very...
You move the flight stick, and the aircraft starts to react after a second. Actually, that's a best-case scenario.
It could be more. So it turns out that in the case of a proprietary server, it's implemented much more simply. There, in the case of server computation, there are other tasks for the clients, and the clients are basically, they just render what they received from the network, you see, and predict the behavior of the player and the kinematics of a vehicle. And in this case, let's say if we are talking about, when we're talking about the distributed implementation, if we don't have a proprietary server, relying on the client machine, someone else's, it's not quite correct, especially considering if this client can still mess up the incoming traffic for themselves. Here, yes, that is here, got it. It's possible to try and make predictions out of this case as well. Kinematics and all that, but it will be much less reliable than with a proprietary server, and that is currently unavailable to us because the aerodynamics are quite detailed and complex. And not just the aerodynamics, but modeling the entire world is much more complicated than our example, Counter-Strike.
Well, yes, even if you take tanks, despite tanks being much lighter, in detail, a tank is much easier to compute than an aircraft. Anyway, it takes a decent amount of resources, and if you run 100 of them on one server, there will be problems. So, this problem isn't just in a flight simulator. You can encounter it in other simulators too, that have ground
by the way,
battles.
If you think about it, for example, racing simulators like...
Yeah,
that's
the example I wanted to bring up.
Yes, it is mainly distributed computing there, precisely because...
Although it would seem it's just a car, with engines, 4 wheels, and no complexities in the form of some mega hydro systems. But, nevertheless, it has its quirks. Like the car must very precisely follow the track and all its bumps. You need increased processing frequency, and again we come to the same point that a large computational resource is required for each.
For example, it's not a flight simulator, but a racing simulator. Let's say if these are race cars, they move at speeds, well, over there it's 100 kilometers per hour, and above 200 it goes like in, let's say, 1/50th of a second. A car can fly through there, exactly, move along on the track there. It can go over a meter or more there.
Well, yeah, It comes out to about 2 meters if at full
It
speed.
depends on the speed. Well, yeah, it will be very high. Let's say a calculation increment heavily influences the quality of collision processing. When there's contact with the ground surface and all that. That is for racing simulators, I would say it's even more critical because if it's a flight simulator, well, the plane is usually in the air, right? And when the airplane is in the air, we have far fewer calculations than when it's in contact with the airfield surface on takeoff. In the case of a racing simulator, what we've got here is constant contact with the surface, constantly at very high speeds.
By the way, it's comparable to the takeoff speed of a plane, pretty much.
Yes, however, no one over there checks the plane to see how it is handling turns.
The runway is usually
Yes.
straight.
So here again, there's a bias to one side, meaning one thing is important here and another there. But in any case, to sum up, in serious simulators, it ends up that we come to a distributed calculation model so far.
Yes. Well, actually, this is the reason why. Why is it that in a flight simulator, it's difficult to do that you could, from your own plane, for example, kill another pilot? That was controlling another plane. Throw him out and get in there yourself. For a flight sim for now. Well, it's hard to implement. Let's say that.
By the way, speaking of take another vehicle, like in GTA, for instance, GTA, for a long time, they couldn't implement the network feature for some time. But later, a network implementation appeared. Honestly, I haven't tried this network play yet. When I play GTA, it's mainly single player there. But in GTA, it's also an open world there. There is also a lot, let's say, requirements for the equipment because there the character mainly moves in cars. Well, and there was no online implementation for a long time, although it's necessary there. That is, after all, it's not a full-fledged auto simulator, and maybe they found a way there. They either made it work on a proprietary server or they left it distributed. Well, anyway, it's a question for Rockstar Games and not for us. How did they do it there?
Yes, by the way, this is, among other things, a characteristic moment that, well, when you're developing your own engine, you can look up, highlight some approaches, ideas. You can peek not just at similar games, like direct competitors, but also in completely different genres. In genres that don't seem very related to what you're doing. But actually, from a technology standpoint, it's all pretty close. Right. And sometimes it's interesting to peek into things not just in flight sims, but they're like in Battlefield and in GTA, as you said. And in other games, there are also interesting things to see. Nevertheless, we have taken on the task to implement an exit, for now, in single player, for the player to leave the plane and get him back there, meaning you can climb in, climb out, you can exit the plane when it crash lands there, somehow. We'll explain why we did this a bit later. The question now is, what path did we have to take to do it? Because it wasn't an easy task, even in single player.
Well, we should mention that on the network nevertheless. Yes, in the case of distributed computations, it's still possible to do it, but with some caveats. But it's possible, yeah. Complete interaction, like getting into some kind of vehicle, yeah, this is single, if it's a single player. And that's the main difference from what it used to be. Let's say, if you had a character model that was kind of, let's say, a draft, we initially had the possibility to get in, to sit, but that was just a draft and it wasn't fully realized. Now we've completed it, basically, but to some intermediate end, naturally, it can be improved infinitely.
Yeah, as usual.
But in principle, yes, we have connected what we had previously planned. These bots, characters, yes, they have the most specifically walking characters who. So what's the main problem there? The problem is that, let's say, it should be physical-based behavior, but at the same time, not physical behavior. one mixed with another, we usually get a character that is controlled by the player, like this. If it is a common character, then it will be controlled by AI too, and he usually just walks straight. And usually for the player's convenience and the overall gameplay, these characters shouldn't be like weebles. That means they shouldn't fall over but walk upright. What's the contradiction?
This contradicts
as they
physics.
said in the movie?
Yes, because in physics, if you put something long on its end, it tends to fall over naturally,
That is,
right?
if we do not make a complete model, let's say, of an anthropomorphic humanoid with all its bones, muscles,
with all the forces
and
in the
even
joints.
the spinal cord. Then, in principle, well, in this case, if we make a fully anthropomorphic model, we get basically just a model of an organism. Well, a kinematic one. Well, but we do have a flight simulator instead. And the game as a whole, so we have to balance these things. Well, sort of, we have physical interaction with the world, but in some cases certain, let's say, tricks to make it. The player didn't feel like some sort of tumbleweed being rolled around. He should move by himself and be able to fully control his actions. So, the controlling fully corresponds to what we see on the screen. His character does. So, well, what? Yeah, so on one side we have the character physically interacts with the world, meaning he participates in collisions.
He gets on the plane.
He can climb on a plane, and he can move himself, and he can walk on movable platforms accordingly. On the other hand, it partially, let's say, limited in its kinematics. It remains, let's put it this way, in a vertical position. So we end up with it kind of like, it's like a non-physical physical aspect of its kind. So based on that, what's so interesting that we can say about this? This is also related to different states. Lying on the ground there, jumping, all that stuff. Or like swimming. These are all different specific cases. The main problem is that we end up fitting. So we're creating some big state machine, which is also tied to physics. That's because we are in the physical environment and we need to interact with physics. Like if we were making some kind of Super Mario game, let's say. It's just two-dimensional movement, so to speak, of 2D sprites and all that, with states, with animations. So here, we need to tie it all together to the extent that it all interacts properly with the aircraft there. With diving in the air, parachutes, jumping, floating, crashing, it should all be drowned, shattered, complete. The interactivity with the environment should remain in this case.
Yes. You have to understand that if we take, for example, Counter-Strike, or a similar game, there is a set of interconnections. Interaction! With this bot and certain objects, it's quite limited. You either run around on the surface, bump into a cube, climb onto something, or collide with someone. Here, yes, we can fall. We can fall on a tree, fall on a house, fall into the water.
In fact,
a plane can crash into you, a machine gun can fire, and a bomb can explode nearby.
Actually,
and all of this needs to be handled.
Counter-Strike is, in principle, a good example from the point of view that there, among other things, still, this task is also implemented somewhat closely to ours, especially if we talk about the source engine. Basically, everything is fine with it. Well, naturally, they don't aim to, like, for example, have a character laid down with a rifle, for example. Yes, and he could be run over by a tank or something. I mean, there are simply no tanks. But basically, if we talk about Counter-Strike, the task is pretty much the same, and, well, it's solved a bit differently. But the task there, a bit different, but in principle, in implementation, conceptually similar. Yes, similar.
Interesting. Such things, look really different from the outside and from the inside. That is, what we perceive as unlike, the person who is involved in this will perceive it as something very similar. And that's exactly why it's always interesting to talk to developers. Take advantage of the opportunity. What else would I like to discuss? And what else I'd like to discuss accordingly. Here I'll probably explain what the initial goal was and why we even got into this topic. And when we started in our work on all this, the question was which game mode we would primarily focus on. Earlier, Zhenya Isaev and I talked about how our main mode is the pilot career. But generally speaking, one of the options was this scripted campaign with solo missions, scenarios, videos, and all sorts of things. Old school. And within this topic, the idea was that you start the mission as a character, meaning you can move around, you have a body, and you start in a tent. You are briefed by your fellow officers. Get in a jeep, drive it to the parking lot, get out of it, get into the plane, and fly to the mission. And, in fact, within the framework of this idea, we began this development. And really, we have no intention of giving up on her, because everything will probably be fine when the game gets out. If it sells well, if you all will buy it accordingly, then, well, this idea of a scenario campaign, it might actually be possible to implement such a feature like this. Even without a campaign mode, this feature is still worth it. It deserves to be in the game because it gives you extra interactivity. Before, if you jumped out of the plane, that was it. The game was over for you. But now you can do something else. So for you, immersion provides some extra presence. Also, we are often asked by players on social media whether it is possible to add in a feature whereby the game view from the visualization of the body, the pilot's body, from a first-person view from the cockpit. So, we actually did it. But here's why we didn't do it earlier. And what's difficult here? Accordingly, and why is it difficult, let's say, to make a first-person view when bailing out?
As for the cockpit, we actually, basically, why didn't we do this before? Because mostly, I would say, such a task wasn't given. Because, well, obviously, there are some complexities, mainly related to how to show the body while, with the camera, you see your body, yeah, but you can freely move this camera and observe a cut at your neck area, so to speak. The torso, where the camera is and all that, the question is that the camera, which... Pilots, yes, the cockpit camera. It is currently unlimited in its movements in the cabin, yes, and to make it look, well, acceptable, well, visually speaking, yes, sort of. Well, either you have to put up with some flaws of the pilot model, yeah, or you need to make some, let's put it this way, some peculiar tricks. But in any case, it's not exactly the same as, let's say, talking about a game where the player just moves in first-person view, that is, sees their legs but naturally will not see their own neck, because there's no freedom of head movement there. He just walks around. But here we have a cockpit. We give full freedom, 6 degrees of freedom. Yeah, especially if you think about VR. With VR, there's even... Back in our time, we had a restriction inside the cabin and users requested to remove it, and now they can move the camera outside while sitting in the plane. And with VR, yes, on the one hand, it's convenient to have a body, but on the other hand, if you look the wrong way, you can see weird things. That's all?
Yeah, if the camera gets into the hand, for example, and what we see there. Right. So, and the second complexity is that Great Battles has a very large legacy. There is a lot of content and an enormous number of aircraft, more than 100. And it turns out that to create the pilot's body, you need to make unique animations for each of these planes, like how the pilot holds the control stick, how he moves. With 100 planes, that's too costly. And now, accordingly, in the new project, we've started the content from scratch. All content is produced anew, and when it is made anew, if we anticipate this right away, we can realize these opportunities accordingly. About the parachute. Why is it difficult with a first-person parachute?
Well, again, the parachute issue. It's an issue, but let's say of an acceptable outcome. A generally acceptable result, that is. And turning on the camera there isn't hard. We even had it before, I think.
Well,
when we
yeah.
first made the parachute, we had a first-person perspective, but we turned it off because of parachute cords and mounts. Well, in general, it's a matter of how to model this parachute to make it look good, because again, while hanging from a parachute, the player can look up and see all the straps leading to their face. So, it's a question of modeling and question. How convenient it really is. Not just how convenient, but how good. How good to do it from the perspective of how it will look exactly. It's not so much a technical issue as a problem of modeling and bringing it all together, because in the cockpit the head moves freely. But in a parachute, we hang on the straps. These straps somehow have to go over the shoulders, and still, when looking up, it should look adequate. Without any clipping or anything like that, and there you go. There are also issues with shadows. Because if we are in the cockpit, there are more detailed shadows than outside of the cabin. Well, if we are on a parachute, then the parachute is already outside of a close-up view range, and there will be different shadows. A little worse or a lot worse than, say, from myself. So here's the thing with my case. The question is just how well can we do it, considering the
We can turn on the camera
result?
at any moment, but the question is,
and again,
how good
what
does
about
it look?
VR? I mean, you're skydiving and you've got VR. So what are you going to do with that VR? I mean, you'll end up being able to walk around the parachute. That's how it goes.
Well, yeah.
Well, that's odd. Yeah.
And now, and I guess this is the last topic for today, since we've already spent half an hour accordingly. Where do you see the development of the bot heading? What other directions could have been explored here? And maybe not in the flight simulator genre in general, specifically within our engine.
Well, you can develop, let's say, in various ways there. For example, improve the physics and add stuff there. Let's say, add solid-state interactions within the bot's body itself. You can address issues there and improve the networking, whatever it's... interactions, that is, with other airplanes, so that there might be a distributed control. Again, the point is that we had an idea about dual control. We have already started working on dual control. Well, dual control is just such a case, let's say, when, suppose you're flying on another player aircraft, but you're still in your own cockpit. So you have your own space, like a pilot's, and that space is still modeled for you. That is, the dual control makes it way more feasible compared to, for example, a proprietary server from scratch. Well, here it is.
Although, and in fact, many times we have thought about exactly going in that direction. A Battlefield-like proprietary server has been discussed many times. It's not an impossible task, it's just that it's very,
even
an
if we
aside.
say we want to
What are
do
we talking about now?
Battlefield, it turns out we have to explicitly simplify the physics of objects.
Blah, blah,
See,
blah, blah.
they should be simpler in both management and modeling, since a proprietary server can't handle many objects because we have gaming rooms with 50, 60, 80 people. And by the way, you have to understand that this is a game room. It's actually supposed to work on, let's say, a usual server when We are renting, for example, a server, and we get some resources. So, well, let's say it's still impossible to occupy the entire CPU time.
Yup.
So we can't, let's say, to run 8 gaming rooms on all, say, 16 cores and thus occupy the entire processor. In an ideal case, it should be so that this proprietary server could handle 100 aircraft without any heavy computational load. But in this case, in this niche, in the niche of flight simulators like this, implementing with such detail, yes, that's of course problematic. Either we need to simplify or we need to find some sort of compromise there.
But, in my opinion, it's quite obvious that if you move towards a Battlefield-like game, this means moving away from simulation too. Naturally. So it's a genre shift. But nevertheless, in the engine that Sergei has been working on for many years, a foundation exists even for that. So basically,
if we wanted to,
we could do
well,
it,
yeah,
I guess.
but I'm really not sure we can translate our aerodynamics to this, but anything is possible,
To
right?
be continued.
Yes, so well, let's...
Maybe we should answer that question a little bit.
So, what interesting things do we have here? Actually, we've already answered some questions along the way. Probably most of them. All right. Here is a question. Previously, it was mentioned that... Well, I mentioned that. We have a bot. Well, a pilot. If he leaves the plane and falls into the water, he will be able to swim. So, accordingly, here. It's interesting, accordingly. The question is, why are we doing this, right? And what difficulties does it cause?
Meaning we could do something more useful.
Well, kind of.
Yeah.
How to say? Because,
Well,
in
look,
general,
we're making a
yes.
simulator, right? Like
But
a
how
simulator.
does sinking like a brick make this a simulator?
We must strive and at least try to make it happen. We must strive to recreate, model all the situations, besides the fact that we have a plane flying and we have a pilot. And if he also, let's say, can jump with a parachute, then he can also drown with that parachute. Here, especially since Korea is partially a game about the sea,
Yes. And besides, our next project will probably be Pacific.
Yeah, that's why. Well, a bot needs to be able to swim and interact with water because even if you don't control and don't walk or swim, the characters themselves still should. Under AI control, they should have some capability to interact with water. At the very least, because again, we also changed the rendering for this. That is, now we have a visible underwater part of everything.
Yes, that's also an interesting
and the
point.
fact that...
Without changing the render? Yeah, not doing. Some improvements, well, specifically, so you can see what's underwater in a semi-transparent view, these kind of features. They become very controversial because if you're going to have a floating pilot, yes, being in the water, if you don't do that, you'll look like you've got a chopped head, but it will appear as if the head is cut off and it's floating on the surface of the water. Not very good. So the combination, the sum of what we've done in physics, and the graphics allow us to work on such features now. Well, we'll probably cover one more question today. So, we talked about the first-person view while bailing out. Ah, that's a good question. How will the pilot's animation be implemented? Will mocap technology be used? Or will you go old school yanking a puppet? It even feels this person talks like a pro. Well, first, we should mention what a mocap is, basically. Probably. You say? Well, let me say it. Mocap, actually, has nothing to do with game technology. Mocap is, well, these are not game technologies, these are content production technologies for animation. In a mocap studio, animations are recorded with the help of actors. And then, accordingly, The animation artist cleans and inserts these animations into a game in a certain way. And yes, we apply these approaches very actively. It should be noted that our colleagues in the studio are working on projects War of the Worlds and Caliber using mocap animation. And they are very experienced, so we have such an opportunity and actively use it. On this note, we should probably wrap it up. Thanks a lot for coming. Actually, besides this topic, there will be more talks based on your schedule. In general, there will be plenty of discussion topics. Please, everyone, give this video a like. Please subscribe to our channel and stay tuned for updates. Bye, everyone.